So anyway, I'm Anthony Macey. I'm an Oracle consultant primarily. I'm also a bit of a data nerd in general. Now, cut long story short, around about Black Friday, I was having a chat with an enterprise architect. Enterprise architect was saying to me, Amazon.com didn't bat an eyelid because it was running on Hadoop. 2 weeks later, I was having a conversation with a guy at an Oracle conference. The Oracle guy was going, oh, Amazon.com didn't bat an eyelid because it's running on Oracle. Actually, technically they were both right, but they both thought that they had exclusivity over what was going on. So essentially, Amazon's a hybrid data architecture. So's Twitter, so's Facebook, so's LinkedIn. So I'm just going to quickly run through essentially what I think a hybrid data architecture is, and essentially the sort of like history of how we got there. So very, very quickly, we've got at the top there, we've got the sort of progression of hardware. So hardware's gone from being really expensive and really slow to being really fast and really cheap. That's the short and curlies of it for a lightning talk anyway. From a software perspective, we've gone from trying to preserve those precious resources and not use them very much, all the way along. While we've been going along, we've picked up a few standards in the sense that we've picked up SQL, and everybody loves SQL. And then we've moved all the way along, and we've now got a multitude of technologies off the back of people like Amazon, Google, who've kind of spun out these patents, and people have spun up things like Cassandra. They've spun up things like Hadoop and various other little bits of technology all over the place. And so we've essentially got this massive ecosystem of different technologies now that exist. So some of those sort of technologies have got different properties. So from a security perspective, you've got your sort of mainstay VBMSs like Oracle that are very, very secure, and have got very, very short critical vulnerability life cycles. So a vulnerability is found, they've got lots of customers who pay them lots of money, so they kind of fix it very quickly. People like MySQL, essentially owned by Oracle, same sort of thing, because Facebook and people like that are basically doing the same sort of thing. So, and then you've got the open source world in the middle, and nobody's, because of open source's support, none of the really, really popular open source projects have got any particularly long cycle for security fixing. On the NoSQL front, in general, most of the NoSQL databases are pretty poor in terms of security, whereas there's one in particular at the moment which is sort of coming to the front, which is Cumulo, which is particularly secure. It's got like a very, very, very fine-grained level of security in it. In terms of performance, you've got Oracle, which is up there again, but again it's very, very expensive. But also you've got people like Cassandra and MongoDB who are also sort of exceptionally fast. I put MySQL, and Spark in the wrong place. Kind of technologies that are sort of coming around at the moment. Basically over the last year or so, Spark has sort of come along and changed the sort of Hadoop space from being MapReduce orientated to being in-memory orientated, so it's kind of sped it up an awful lot. And then we've got MapReduce and Hive at the end, which are basically batch processing ecosystems that do stuff very resiliently, and they're very, very scalable, but they're very, very slow for doing the type of things like Oracle might do, which is a relational type query. You're talking about doing things in minutes and seconds on Hadoop ecosystem, whereas on an Oracle relational database system, you're talking to do things in microseconds, as in millions per second. So there's a whole bunch of different things, whereas Cassandra, you can do things very, very, very quickly, but you sacrifice what I've got on the next slide, or on the next little thing, which is essentially consistency. So consistency, with things like NoSQL, you can make them very, very fast and very, very scalable, but you can sacrifice on consistency. And again, you've got Oracle, which is very, very consistent, and you can have very, very, very large amounts of data change, because you've got things like update statements and various things like that. But again, it's very, very expensive, so you've got the other things like MySQL, Postgres, and various other types of technologies that are sitting in there. quickly move on to my next slide. It's a bit of a complicated one, this. But essentially, that's over here, the little laser doesn't, I've not tested to see if the laser works. Oh yeah, it does work. So you've got essentially a Hadoop ecosystem over here. The sort of more modern, sort of last sort of 6 months or so type take on it, which is essentially Spark sitting over the top of Mesos sitting over the top of Hadoop. And that's kind of the batch processing elements of most of the hybrid data architectures. And you've got things like Postgres, for instance. So this is all open source, this stack. Mainly because you might be not looking to spend truckloads of cash with Oracle, because you might be trying to start up your business. Your Postgres is going to give you all of the properties of a particularly, all the properties of a SQL database with the ACID transaction identity. When I say ACID, basically what it means is it just means that you can guarantee that the data that you wrote is exactly the same. It basically is exactly what you think it is at any point in time. It's a very, very tight consistency model, whereas most NoSQL databases have got a fairly loose consistency model, and the best of those loose consistency models is something called base, which is basically eventually consistent. It means eventually consistent everywhere. Sorry, I had a cup of coffee here to wake myself up, so I'm a bit blabbering. A couple of people do this type of thing for a price, and there's essentially there's Cloudera out there that build that all for you and deal with all the complexity of putting it together. Hortonworks do a similar thing, which is the Hortonworks data platform. And again, you've got the big players who do essentially their own commercial versions of that. So Oracle basically OEM Cloudera stack into what they call a big data appliance. Obviously, they've also got a Oracle database that will plug into that, so you can actually have, if you had an Oracle stack, a seamless stack across all of those different bits and pieces. And the key to making all of those different things work together is essentially to have some sort of identity management system where you can essentially assert the identity of the user that wants to obtain that data, which kind of alludes to what Guy was saying earlier. The data protection man is basically protecting your data rather than not having any kind of protection in there at all. The next slide. Once you've essentially got that big ecosystem, we've essentially now, the gentleman who was talking about Docker earlier is kind of, that's the next evolution in that side of things. So we've got something called Mesos now, which is what they're calling enterprise kernel. Sorry, enterprise data center kernel. And what it means is that you can effectively deploy Docker type images or containers of things into a container and deploy it across your enterprise in a resilient way, which means that things like Rack, which you would buy from Oracle to make your relational database scalable and very, very big, are going to be in a spot bother when things like so we've got NewSQL, which is basically ACID transactions on top of a NoSQL architecture coming along. That's my, yeah, no, I've got to wrap it up, and that's actually my alarms telling me to put my rubbish out.
These slides will be online.